Today we're going to be talking about the STAAR 8th grade mathematics reference materials, and we are going to go over the cheat sheet together. There's going to be 3 different parts that we go over. We're going to talk about this section right here, then this section together, and then the last thing, additional information. Okay. So let's go ahead and look at what you guys will be able to see during STAAR. And the first thing we have is linear equations. First, we have slope-intercept form. This is going to be those non-proportional questions, right? And in there, we have this y equals mx plus b, and we know its slope. X is the variable x, and then b is going to be the y-intercept. Let me put that a little bit clearer. Okay, so where it crosses on the y-axis. Okay, then we have direct variation. And direct variation is the proportional, right? The proportional type of questions. Remember, whenever we have proportional, we have questions that say the directly y varies directly. Right. And we also know that this goes through the origin 0, 0. Right, on a graph, it goes through the origin. Remember, this is called the origin. Okay, and here we have y equals kx. K is just another thing for slope, for m, which is slope. Okay, so an example of a non-proportional would be y equals 3x plus 5, and then a proportional would just be the y equals 3x, right? Because there's no y-intercept, so we can just put a plus 0 at the end, and because it's plus 0, we don't really need it. Okay. Lastly, on this section, we have slope of a line. Remember, slope is rise over run. Like in a table, we have that change of y over the change of x, where we have a table x, y, and we have like these numbers, right? And we find the difference between two of the sections. Okay. Remember, you only pick 2 sections, 2 rows to look at the slope. The ones that are right next to each other. Okay. And here we have y2 minus y1 over x2 minus x1. Those are just as if we have 2 points, x1, y1, and x2, y2. And we can put that in the calculator as well. Okay. So let's go to the part where it talks about area and surface area, volume, and circumference. So up here in circumference, we have circumference only applies to a circle. So in a circle, we have this part, which is the radius. That's going to be the r. And then if we have a circle, the diameter, the entire thing is going to be the diameter. Okay. So you can put it upways like I did, or horizontal like I did the first time. Okay. Here we have 2 formulas for circumference. Circumference is the perimeter around the circle, right? So it's going to be this part right here. Here we have C equals 2 pi r, where r is the radius. I'm going to just write out radius. Or you can put that it's pi diameter, pi times diameter. Okay. Then let's look at the area. So here we have triangle, rectangle, or parallelogram, trapezoid, and circle. So we know how each one looks. Let's just draw them real quick. So here's a triangle. A rectangle can be a square. It can be just like a regular rectangle. A parallelogram is going to be one of those slanted rectangles like this. A trapezoid can look like this. Okay. And then a circle, obviously we know what a circle looks like. Okay. Here we have like their formulas, and here we have the bases and radius and pi and all that stuff. Okay. The main thing that we're going to use this section is this section right here, the area section, is to find the big B. So right here, I'm just going to put a really big B. Okay, and where does this big B come from? The big B comes from the surface area. Do you see that big B? And the volume. You see those big B's right there? We need to know what those mean. Okay, so if we go to surface area and we look at prism, prism is basically going to be either like a cube or a triangular prism, where we have like triangles like this, like that. Those are prisms, right? We have lateral and total. Lateral is basically kind of like just the label. Like if we were looking at like a can of soup, the label would be the lateral surface area, and the total would be the lateral plus the two bases. So I'm gonna put lateral plus two bases, right? Whatever those bases may be. The bases might be triangles, they might be squares, they might be rectangles, they might be circles. And so this B, you're going to see, like if it's a triangle prism, that B, or let's actually talk about the P first. Let's talk about this P. That P is going to be for perimeter, right, of the base. And so if we had the perimeter of the base, we just add up all the four sides and we get it, right? H is the height of the prism. And then if we look over here on total, we have that P, which is perimeter of the base. And then we also have the big B, B as in boy. Right? That B is going to change, okay? Depending on whether you have a rectangular prism, you're going to go to rectangular over here, right here. And then you're going to use B times H and replace it with that B. Let's say you had a base of a triangle. We still have that B. I'm not going to use B times H because it's not a rectangle. It's a triangle now. So let's say we have a triangular prism. We're going to use the 1/2 B times height into that B. That B always changes. It's never going to be the same. That's why we have this big B right here, because that's where they come from, right? Let's look at cylinder. So cylinder is going to be just a kind of like a can of soup, like that, right? And this one, luckily, there's no big B or anything, but if there was, you would still use that pi r squared, okay? But luckily, they already have it here for you, okay? Because this is technically 2B, the pi r squared, they're the same. You guys see that? Because you're adding the two bases, right? Let's look at the volume. Let's draw what each one looks like. So prism or cylinder. Same thing. So prism can be like a rectangular prism. So let's say you have something that looks like this, or a cylinder that looks like this, right? Volume is going to be the stuff inside like water, right? Inside a shape. Right. So if we have a prism or a cylinder, we have V equals B times H, big B. That means that we're going to go over here to find that B. This B is never going to be the same. Let's say you were looking for the volume of a cylinder. The area of the cylinder is a circle, so you would go here, and this pi r squared would be that B. So technically, for the cylinder, it would be pi r squared times height, right? let's say it wasn't a cylinder, let's say it was a rectangular prism. So we have a rectangular prism. We go over here where it says rectangle. My big B is going to be B times H. And we will have it there. So here on this one, it will be area of the base times the height of the base times the height of the prism. Okay. And then let's look at pyramid and cone. So a pyramid and cone, pyramids they have like a square base, and then they come up like that. And then we have a cone where it's kind of like an ice cream cone, just like that. Same thing here. We have a big B. That means if you have a pyramid, the base is a square. So you would look right here where it says rectangle or parallelogram. Use that BH and replace it with that B. If you're looking for the volume for a cone, the base of the cone is a circle. So that big B would be pi r squared, because that's where the circle is, and you just replace that big B with pi r squared. Remember, B is never going to be the same if you have a rectangle, trapezoid, circle, or triangle. Okay. Lastly, let's look at sphere on this one. So a sphere is going to be like a circle, a ball, right? We have kind of like that. It's the best I could do. Here we don't have any big B, so we don't have to worry about it. Okay, so it would just be 4 over 3 pi, 4 over 3 times pi times radius cubed. Okay. Let's look at the last part where it says additional information. We have Pythagorean theorem. We know Pythagorean theorem is only for right triangles. Right, and so we have a right triangle. We have our A and B be the legs, and C is the hypotenuse, and that's why we have A squared plus B squared equals C squared. Okay, simple interest and compound interest. So we have for simple interest is P times R times T. P is the principal, which is how much you're borrowing, or how much you're investing, right? Is usually money. R is the rate, and you have to get a percentage and turn it to a decimal. And we do that by moving the decimal 2 times to the left. And then the T will be time. T is time. Okay. Luckily, the P, R, and T are still used in compound interest. Here we have P, R, and T. T is an exponent. And remember, simple interest will only give you interest, and then compound interest will give you the interest plus the total amount at the very end of whatever time period you have borrowing that money or investing that money. Okay. Last thing that I want to talk about is just a picture of a slope. Remember, we have slope dude where he went up the mountain, then down the mountain, then it was straight, and then he went down, right? So when he was going up the mountain, it was positive. Positive slope. When he went down the mountain, it was a negative slope. When he had no fun, right here in this horizontal plane, it was 0 fun, so this is a 0 slope. And then when he went down the cliff, it was undefined. Okay, and this right here is part of slope.